terms of how to choose the right plot, a good rule of thumb is to just try out a line plot, and in a lot of cases it can give you a good enough result. But then once you want to go beyond, then you start looking through this list. Okay, a scatter plot makes sense here. Will it be interesting to use a heat map here? And a lot of these things just come from experimentation. Now take the same data and try to draw different kinds of plots with it, and see which plot gives you the most information and presents the information visually in the best fashion. All right, and as you experiment with it, you will start to cultivate an intuition for which plot to use where. Now, one last thing we should do is to just commit our notebook from time to time. Remember that we're using Binder, which is a temporary online service, so it can get shut down if you leave the computer idle for some time. So whenever you're working on Binder, just do commit from time to time. Okay. So with that, we complete our discussion of data visualization. So let us open up the course project. This is one of the most interesting parts of this course. So the objective of the course project is to apply all the skills and techniques that you have learned during the course onto a real world data set. And the thing about the course project is, well, to get it accepted, there is a certain evaluation criteria that you have to complete, and we'll talk about that. But then it's really open-ended in the sense that you can do as much with it as you want. You can end up drawing dozens of different types of graphs and answer many different questions. You can combine data from many sources. So use this to really practice all the skills that you've learned. Don't take it as something that you just have to submit. Take it as something that you will showcase on your portfolio. And we'll tell you a lot about that as well, that how you can showcase this on your portfolio later on your LinkedIn profile or elsewhere. So let's open up the starter notebook. The starter notebook contains all the information, all the guidelines for the course project. So the first cell of the starter notebook contains guidelines, and then there is a template that you can use, but you do not have to use this template. You can start from scratch too. The way to start from scratch is to go on your Jovian.ml profile and then click new notebook and select blank notebook, and that will create a blank notebook that you can start working with. But in this case, I'm going to use this starter template, and then I'm going to click run on Binder. So let's just give that a minute to load. And coming back here, if you have questions about the course project, once again, there is a discussion going on, so you can ask questions on the discussion thread. And all the instructions are given here too, the same guidelines that are there in the starter notebook, so you can refer to them here too. Let's give this one more try. Okay, so while the Jupyter notebook starts up, let's start going through the guidelines. As I mentioned that this is the starter notebook, and you will pick a real world dataset of your choice, and then you will apply all the concepts that you've learned in this course to perform exploratory data analysis. Okay, and this seems to have opened up. So let me just open up the Jupyter notebook here. Alright, so the first thing, the step one, is to select a real world dataset. So you can find and download an interesting real world dataset, and we have pointed to a lot of interesting datasets in the recommended dataset section. So you can just scroll down below and you will find recommended datasets, and we'll spend a little bit of time there too. And the criteria is that this dataset should contain tabular data, which is rows and columns, and preferably in a CSV, JSON or Excel formats or other formats that can be read using pandas, because we have used pandas primarily for this course, and if you are able to read the data using pandas, you will not be able to analyze it. If it is not in a compatible format, then you may have to write some code to convert it to the desired format. So remember, we also had a discussion about reading and writing to files. So you may have to read it using pure Python and then write it back into a CSV or a JSON format, which can be read using pandas. Okay, I would suggest that if you're not too comfortable with Python yet, don't do that. Just pick a dataset that is already in the CSV format and just run with it. But if you are feeling comfortable, if you really like a particular dataset, it's not in a CSV format, then you can just convert it into CSV as well. Then the dataset should contain at least 3 columns and at least 150 rows of data. Now this is important because so that there should be enough in the project. If it is just 1 column of data and 100 rows of data, then you're not going to have enough to showcase when you present this project, let's say while you're applying for an internship or a job. So just pick a data set that is large enough. Now when I say at least, this is just a lower bound. You can pick data sets with tens of thousands of rows of data. Probably bigger than that will slow you down. So restrict yourself to maybe a few thousand rows or 10,000 rows or so. And you can pick data sets with hundreds of columns. Once again, that will probably once again cause a lot of confusion. So stick to maybe something around 10 columns. A maximum would be good. But as such, the data set should be rich enough that you can ask enough questions and draw enough graphs and so on. Okay. One thing that you can also do, and this will be great because it will really enhance your skills and your experience, is if you can combine data from multiple sources. That will let you create something really unique. And you've learned how to combine data using the merge function in pandas. Yeah, so just keep that in mind. Those are some guidelines for picking the right data set. And we'll show you some examples. But once you have picked the right data set, then next step is to perform some data preparation and cleaning. So you simply load the data set using pandas. And then the same way we've done with the COVID data set and a few other examples. And then you explore the number of rows and columns, the range of values. So you use things like info, describe, shape, and such. So just to get some basic understanding about the data. This is like some meta information about the data. You also decide how you're going to handle missing values, maybe fix any incorrect values, maybe drop any rows that you don't want to consider. So there's some basic cleaning up that you might have to do. And you can also perform additional steps, like you might want to parse dates into the date time format. You might want to create additional columns or merge multiple data sets. So you do all of that. That's the data preparation step. And so take these steps as a guideline on what to do and not as something that you have to really stick to. You can work on the data as you see fit, but these are just some guidelines to help you along the process. Okay. So once you're done with the data preparation and cleaning, then you will perform some exploratory analysis and visualization. So what this means is you will compute the mean, the average, the sum, range, and other interesting statistics for numeric columns. So here we are still discovering, you're going one step deeper where you're looking into specific columns. Maybe you can use this, you can look at the distributions of numeric columns using histograms. Maybe you can explore relationships between columns using scatter plots, bar charts, and things like that. And also make a note of interesting insights from this exploratory analysis. So here we are not really trying to ask any questions yet. We are still just exploring we're just feeling it out. And through that, as we plotted some graphs, we got some, we could infer some things from it, or we could form some hypotheses. So make a note of all of these interesting insights from this exploratory analysis. And then the next step is to ask and answer questions about the data. So now once you have become familiar with the data, you've looked at it in different ways through graphs and through summaries and things like that. Now you have to figure out what are 5 things, at least 5 things that you want to know about the data set. So ask 5 interesting questions, so questions 1 through 5, and then answer these questions either by computing the results. So you can use NumPy, pandas, the different functions that we have for computing the results, or by plotting graphs. So the questions do not have to be numeric questions. The questions, in fact, sometimes even if they are numeric questions, let's say which country has the highest population, if you're trying to answer that, you can actually draw a bar graph and use the bar graph to answer that question, right? So there's no automated evaluation here. It's more for you to explain what's going on in the data, and you get to decide your own questions. And you can create new columns, you can merge multiple data sets, and you can perform grouping and aggregation wherever necessary. And one good thing to do is, in all of this process, apart from writing the code, you should also try to write good explanations. So make it like a tutorial so that it is useful to read for somebody who is one step behind you, for somebody who has not taken this course. So in that sense, it becomes like a full report and a tutorial as well. So whenever you're using some library function from pandas, NumPy, or matplotlib, just explain briefly what it does, or link to the documentation that we can use the pandas.readCSV function to read a file in the CSV format, right? Just one sentence like this, even though it's obvious to you, it's really helpful for a reader. So that's where you will ask and answer some questions. And then finally, at the end, you have to just conclude. So treat this Jupyter Notebook as a project report with the code itself. So just write a summary of what you've learned from the analysis, include some interesting insights or graphs from the previous sessions. So you can once again copy over the code and then just include those graphs if you need to. Again, all of these are guidelines, so you do not have to stick to them perfectly. And then share ideas for future work on the same topic or using other relevant data sets. You have gathered some insights, but maybe you've not really figured out everything and you maybe did not have the time. So you can just mention these are a few other things that you can try out with the same data set. And maybe even point to some other relevant data sets which can probably be combined with this data set, or maybe the insights can be combined to get something more interesting out of it. And this could be an idea that might help you in the future, that this is a starter project that you do, and then 2 months later you're looking for another project to work on. You can just look through the future work ideas from your current project, your previous project, and see if any of those make sense to pick up. So this is a very important thing to do. So do some reflection and then share more ideas while you are still in the thick of things. And finally, while working on this project, you will probably refer to at least a few dozen blog posts, articles, documentation pages, Stack Overflow answers, and some of these you might want to just note down and keep a track of. So just keep a note somewhere of the most interesting links that you found, and just link to those resources at the end of your analysis. All right. And in this entire process, from let's say step 2 to step 5, all of this will happen in the Jupyter Notebook. So document your Jupyter Notebook, write detailed explanations, use the markdown cells, use the markdown syntax, use headings, use bullet lists, use tables. So there are a lot of things you can do with markdown. So just make it a point to make it as nice as possible, because when you send this notebook to somebody, you want them to look at it and you want them to look at it and be able to understand what's going on, and also really appreciate the effort that you've put in. And that will really help you make progress, because presentation is a very important part of data science, right? So that will really help you make progress towards getting a role or getting an internship, a fellowship, or a job in the data science domain. Okay. So now once you're done with all of this, and then you can use this, you then need to make a submission. So you can use this starter notebook, or you can just start a new notebook from scratch, but make sure to keep running jovian.commit from time to time. So here we have a project name. Just give this a nicer project name, whatever makes sense for you. Let's say if I'm working on some COVID-19 data analysis, that's a data set, a real world data set, something that is evolving on a daily basis. Okay. So I am just setting a project name, and then just use the Jovian library and keep committing the project. So here I've created sections for you in the starter notebook. So let me just make a commit first, and then I'll go through that. So here we just put in the API key and then make a commit. But here you can see some sections like data preparation and cleaning, exploratory data analysis, asking and answering questions, inferences and conclusion, and then references and future work, right? So you can just use that as a guideline and write some explanations, write some code, plot some graphs, get some results, and keep committing from time to time. And then when you're done with the entire project, when you feel that you have something significant enough, then you take this committed notebook. So in this case, 02 Pandas course project starter is what I've committed to. You take this committed notebook and then come back here to the assignment page, course project, and make a submission here. Sorry, and make a submission here on the make a submission form, and then click submit. Oh, sorry. So this needs to be, let me just try that again. So this is the notebook that let me just run jovian.commit. So I have committed the notebook. I take the notebook here, the notebook link, COVID-19 data analysis demo that I just committed. I come back to the course project page, and here I make a submission and click submit. And a submission will be made, and then we will evaluate it. Okay, so now what are the evaluation criteria? The evaluation criteria is this, that your submission will be evaluated on these criteria, that the dataset must contain at least 3 columns and 150 rows of data. So this is just so that it has enough of a breadth, enough information within the data. You must ask and answer at least 5 questions about the dataset. So asking the right questions is also a skill. So that's why You have to come up with 5 interesting original questions about the dataset. Your submission should include at least 5 visualizations or graphs. And once again, try to make these different, but we're not going to test if these are all different graphs, but don't make just 5 line plots. Try to use different kinds of charts, scatter plots, histograms, heat maps, whatever you can try out. Your submission should include explanations using markdown cells. So it should not be just code. It should not be just a series of code cells, because then it shows that you've not really put an effort into presentation. Presentation is an important part of data science, and especially of doing projects. And then your work must not be plagiarized. That you should not have copy pasted the entire thing from somewhere else. Now you can see a lot of these data sets are already analyzed. There's a lot of information available online. So you can repeat what somebody else has done. But just there's a difference between simply copy pasting where you do not really understand what has happened versus borrowing the right things from specific notebooks or tutorials. And it's a fine line, and it's something that you should hold yourself accountable to. But just try to, as long as you have put in some original work into the project and you have satisfied all of these criteria, we will evaluate and accept your project. And this course project, along with the 3 assignments, if you've completed all of them, then you will be able to earn the verified certificate of accomplishment that you can add on your LinkedIn profile or wherever else you want to. So these are the evaluation criteria. This is how we will evaluate your work. Now, I just want to spend a little more time talking about some of the interesting, some of the data sets that you can use for working. So we have created a list of a few data sources from where you can get data sets. So the first one is Kaggle datasets. This is the easiest one to get started with. So you just click on Kaggle datasets and you will find a whole bunch of, there are over 50,000 datasets you can pick from. So for instance, what you do is just open up a dataset and then just click download, and that is going to download the dataset for you. And I'm just going to save it on my desktop, and I'm just going to open it up. So unbundle it. So you can see here that there is a file here. So from 1976 to 2018, you have the data for US Senate. Let us open it up in, let's use Visual Studio Code to open it up. So you can see that this data is in CSV format. This data is in CSV format, and in the CSV format, you can now read it using pandas, and you can start doing your analysis. So that's one example, the US elections dataset. And there are lots more that you can look through here. You can also filter. There are a lot of filters that you can use for this dataset, for these datasets. So that's Kaggle datasets. Then similarly, you have the UCI machine learning repository. This has a whole bunch of datasets too. So here you can, for example, just click on view all datasets here, and you can see you can even filter it out with different areas, different attributes. You can see different data types and different instances, and use that. So here, for instance, breast cancer dataset. So this has around 2000 data. You can see a basic information that it contains a bunch of information about breast cancer patients, and you can find the data folder here. So here it is in a certain format called .data. You might want to then convert that format to CSV. But a lot of these datasets are also in a specific CSV format that you can directly use too. Okay. Then you have awesome public datasets. This is also another great source. So this is a GitHub repository from where you can find links to a lot of datasets in many different areas. So if you are from a different domain, like whatever domain you're from or you're currently working in, find an interesting dataset there. Use that. And then you have, we also link to a place, you have Google Dataset Search. So on Google Dataset Search, you can find data for anything and everything pretty much. So for instance, if we try global temperatures, you can see that there is some data here about global surface temperatures, and you can then get this data. So in some cases, you might have to go through a few links to get the data, and you might have to look through on how to actually download the data. So I'm not sure here what, it seems like there's a lot of different data files here. But as you just go through and look through all of this information, you will be able to find a CSV file. If not, probably just try another dataset. So these are some sources where you can find these datasets, right? And whenever you get a dataset downloaded to your computer, Now you will need to upload it back to Binder. So here, whenever you're working on it, you will need to just upload this data. So here, for example, you have the USA presidential election by county. I'm just going to upload that. Actually, let me upload a smaller file. So here, let me upload this 2012 data. So this is how you upload a data to Binder. And if you want to download a file, let's say you've created a CSV file by processing some other data file, you can download it by selecting it and clicking the download button. So that's something you can do as well. One other thing that you can do is when you're running jovian.commit, you can also include a bunch of files. So for instance, here in the list of files, I can include this CSV file name. So in this way, what happens is that your CSV files can get included. Your CSV files can get included along with your commit, so that the next time when you run, then the CSV file will automatically become available to you. So the first time you run commit, you might want to just include the CSV file using the files argument. So then when you commit and you check the files tab of your project, you will be able to see the file here. And when you run it, the file will already be present, so that you don't have to upload it again and again. Okay. So that's how you work. So these are some dataset sources, and then we've also picked out some specific datasets like the Stack Overflow Annual Developer Survey, some COVID-19 data, some Google Play Store data, and a bunch of. So these are datasets that we would highly recommend that you can analyze. So there are some game datasets like Dota, cricket, basketball, PUBG, and so on. And then there is also data that you can download from your personal apps that you use. So things like WhatsApp, Chrome, Google Calendar, Apple's apps, Instagram, Facebook, LinkedIn. And that is also another really interesting thing to do. So now what I want to do is I want to show you a few examples of what a good project will look like. And actually one last thing that I want to mention is that apart from making a submission, you should also share your work on the forum. So a submission is more for us to evaluate your work, but then you can also go on this forum thread, the course project on exploratory data analysis, where you can share your work. And we are hoping that we see thousands of projects shared here. And when each of us share our project and then go through maybe 5 to 10 other projects, that way we learn a lot more than we would learn individually. So please share whatever you do. Please share ideas. So on the datasets thread, you can also share ideas for datasets. On this thread, you can share ideas for projects, share an update on what you're working on, how your notebook looks like so far, and keep sharing updates on a day-to-day basis and support each other. And that's how we can all create maybe 1,000 or so interesting projects. And you can also share these projects on social media and just tag us, and then we will be retweeting 4 or 5 interesting projects every day. And do try to give feedback to other participants too. Now, apart from that, there is one optional step here, and the optional step is to write a blog post. So you can have a Jupyter notebook and you can have great explanations, but sometimes it is also helpful to write a separate blog post. So you can use the medium.com platform. Again, this is completely optional, not part of the required submission. You can sign up on medium.com and you can copy over the explanations from your Jupyter notebook into your blog post. And the code cells and the outputs, you can actually embed them within your blog post. So I'll just show you an example. So here you can see that you have, this is a blog post where we have embedded this code cell from a Jupyter notebook. You can see here that you have the inputs and the outputs. So you have some code and then you have a graph. This is embedded from a Jupyter notebook. They're called Kaggle Python recipes. So you can embed code and output from your Jupyter notebook inside a blog post. So try that out as well. And if you want some inspiration, you can check out our Medium publication, right? And we will love to feature your work on our Medium publication, and we will share it with our user base. We will share it on our social media. So we are looking forward to interesting submissions, interesting blog posts, and interesting notebooks. Okay. Now I want to show you a few examples of some good projects that you can take inspiration from. So here's one. This is analyzing your personal browser history using pandas and Seaborn by Karthik Godawat, a good friend of ours. So here what Karthik did was he used Google Takeout. So Google has something called Google Takeout, so takeout.google.com, from where he exported his entire browser history across all devices, including mobile and desktop, in the JSON format. Then he took that browser history JSON and then he converted that into a pandas data frame. So this is what the data frame looked like, where there you had the URL, and then you had the title, and then you had some other information like at what time he visited the page. Based on that data frame, he extracted a bunch of features, so created new columns. So he created like days of the week, year, month, and things like that. He also created categories. So based on the URL, like if Coursera, FastAI, Kaggle, or Free Code Camp were part of the URL, then he categorized that as learning. On the other hand, if it was Y Combinator, Medium, or HackerNoon, he categorized that as tech reads, and then probably categorized YouTube, etc. as entertainment. So he did some categorization and created a data frame out of that as well. And so that is some pre-processing on the data. Then he started exploring the data and creating visualizations. So here he has used Seaborn to create a count plot. This is something that we have not explored, but you can look up the documentation. So to check how many sites were HTTPS and how many were HTTP, he has done some more analysis to figure out how the browsing activity varies on weekends versus weekdays. So it seems like there's more activity happening on weekdays compared to weekends, so that's great. He also looked at his browsing activity over the different months and the different hours of the day. Different days and different hours of the day. So here it looks like that most of the browsing, so between let's say 12 a.m. to 9 a.m. not a lot of activity happens, and then there's a lot of activity happening on certain nights, probably when you're binge watching something or maybe busy with work. So here a heat map is a good example, and you can see that all these graphs are things that we have covered. Then you also looked at browser visits by the day of week and the hour, again a heat map, and then there are some more analysis. Here this is a list of the most common Stack Overflow questions. So sometimes you don't need to create a graph, you can just create a filtered out data frame. So it seems like these are some of the most common Stack Overflow questions that Karthik looked at, and so on. So this is one great example. Then another one is just analyzing the COVID-19 data using pandas. This is what we did for the pandas tutorial. So you can see that we followed all these steps here, and you will be able to just take a data set and follow the same steps, reading a file using pandas, retrieving some data from a data, then exploring the data, querying and sorting the data. We did not do a lot of visualization, but you can see very easily how you can insert a lot of interesting visualization here. We also asked and answered many questions here. So we've asked 4 questions and answered them. So this is again something that you can review. Here's one where Prajwal used his own WhatsApp data to perform certain analysis. So here Prajwal has downloaded his WhatsApp data and he has given you the instructions on how you can do that too. And based on that, he has then converted that into a data frame. So you can probably even just borrow this function if you want to analyze your WhatsApp data. And then he's done some data cleaning. And then based on that, he's asked questions like who is the most active member of the group. So it seems like this person is the most active. And what were the most popular emojis that have been used? It seems like the laughing emoji was the most popular emoji. What can you say about the sleep cycle? So it seems like there's a lot of activity on WhatsApp happening around after 9 p.m. So these are interesting insights that you can discover about yourself. And then there are a few more. So here's one called Understanding the Gender Divide in Data Science. This is more around data visualization. So you can see this is from a Kaggle dataset, and here Akansha has walked through many different interesting kinds of plots that you don't normally see in Matplotlib or Seaborn. So if you want to explore more interesting plots, you can check out this tutorial. And then there is also a couple more that you can follow. Okay. We are hoping to have a lot more examples as the course participant work on projects. So you can take your projects and then share them on this thread, discuss and share your work thread. And you can also share ideas for datasets on the datasets thread. So we have a separate thread for datasets. This is recommended datasets for course projects. So here you can check out these datasets and you can also post ideas for datasets. Okay. And I hope you're excited to work on this project. We are really excited to put this together for you. We've gathered a lot of resources from a lot of different places, and everything that we have been doing in the course so far has been building towards it. So just take it step by step. follow the guidelines, do something, try to make some progress. So find a nice data set, do some analysis, explore it, see if you want to pursue it and create a full project out of it, and so on. Right? And you can always ask questions on the forum wherever you feel stuck. You can ask questions just simply as simple as, do you think this data set is interesting to work on? And others will reply to you, even the course team will reply to you. And our final lecture is going to be a case study of exploratory data analysis. So in some sense, it is one project that we are doing. And so that will also help as serve as a tutorial for how to take up a data set and then do some processing on it and do the analysis on it and present some results. And we'll just walk through that entire process. Get started now. Okay. Once again, do get started as soon as you can, and I wish you all the best with the course project. And I hope that this will be something that you will be able to proudly showcase on your professional profile. Our final lecture is Exploratory Data Analysis, a case study, where we will be taking everything that we have learned in the entire course and bringing it together into a single project where we will be analyzing a real-world data set, and we will be asking and answering some interesting questions about the data, and we will figure out how to use the right tools and techniques and libraries and functions at the right places, and we will be drawing some inferences and conclusions. So this is in some sense a walkthrough of a real-world project that you might do in data analysis. So with that, let's get started. So the first thing you should do is go to the course page 02pandas.com, and on the course page you will be able to find all the course materials. So today, since we are looking at lesson 5, so you can lesson 6, so you can scroll down to lesson 6, Exploratory Data Analysis, a case study, and click open. This will take you to the course page, the lecture page, where you will be able to see the video. So the video that you're watching right now will be available as a recording for you to review. Now for each lecture, we have been using Jupyter Notebooks. So today we will be using the Jupyter Notebook EDA on Stack Overflow Developer Survey. So you can just click on this link and that will bring you to this Jupyter Notebook. Now you can view this Jupyter Notebook, you can read through it. But what we would want to do is we would want to run this notebook. Now you need not run it right now if you are watching live. You just watch the lecture, and after the lecture you can run this notebook and experiment with it. But I'm going to run it right now, and we are going to work through it. And we click the run button and click run on Binder to start the notebook up on the Binder platform. Now this might take a couple of minutes. And in the meantime, I just want to show you how to ask questions. So if you have questions during or after the lecture, you can come to the lesson page and here click on the discussion forum link. And this will take you to a page on the discussion forum. This is where we've been having all our discussions, and you can use this thread for asking questions. All you need to do is click the reply button and post your question. There's a big blue reply button and you just post your question and hit reply. And either somebody from the course team or somebody from the community will answer your questions. Okay, so please ask your questions on the forum and also answer questions if you already know answers to some of the questions that have been asked here. So returning to the notebook, this notebook is called Exploratory Data Analysis using Python, a case study. And we have clicked the run button and selected run on Binder. So finally here we have our Jupyter interface running. So let's just open up the notebook here, Python EDA Stack Overflow Survey.ipynb. And the first thing that I'm going to do is I'm going to click kernel, restart and clear output. This is to clear all the outputs so that only the code remains and we can run the code and see the outputs for ourselves. Then I'm also going to hide the header and the toolbar. You need not do this, but I'm just doing this so that we have a little more space to work with. So in this notebook, Exploratory Data Analysis using Python, a case study, we will be analyzing responses from the Stack Overflow Annual Developer Survey, and we will apply all the things that we have learned so far about Python, Jupyter, NumPy, Pandas, Matplotlib, Seaborn together, and we'll bring everything together. Now, you can run this code online just in the way that we have by using the run button that we just used to run this code on Binder, but you can also run this code on your computer locally, so you can follow the instructions given here under option 2. Now, as I mentioned, we'll be analyzing the Stack Overflow Developer Survey dataset for our analysis, and this is an annual survey conducted by Stack Overflow, and you can find the raw data and results on this page, insights.stackoverflow.com. In fact, we will be analyzing the results from 2020, but you can also see the survey from the past years. So the first thing that we would want to do is to download this dataset into Jupyter. And there are many ways to do this. We've seen many ways over time across different lectures. So the first thing that you could do is just download the CSV manually and upload it using Jupyter's graphical interface. So let's do that. Let's see how to do that. So you click download full dataset, and that points us to a Google Drive link. And then you can download the Google Drive link. And so here I'm downloading it to my desktop. And then you can unzip the Google Drive link. So once you unzip this link, you will see this folder, Developer Survey 2020. And if you open up this folder, you will see here that you have a PDF and then a bunch of CSV files and then a README file. So you can go through the README to learn more about the dataset. But probably the interesting files for us are going to be the CSV files. So we might need to upload these CSV files onto Jupyter. So the way to do that is to come back to the notebook, go File, Open, and then you will find an upload button here. So click Upload and just select the file that you want to upload. So in this case, let's say as an example, let's try and upload survey results schema.csv. So one by one, you can upload each CSV file that you need. Okay. So that's one way to do it. You can click the upload button to complete the upload, but I won't do that right now. Then there's another way to do it. If you have a direct link to the raw CSV file. Okay, so this is very important. If you have a link which points directly to the CSV file, so a Google Drive link or some other link will not do. It has to point to the raw file. Then you can use the URL retrieve function from the URL lib.request module. So this is what we've used in our previous lectures. We've used this in the lecture on NumPy and Pandas. So you can review those lectures 3 and 4 to see how to use this, or just check the documentation. But today we are going to use a third method. We are going to use a helper library called Open Datasets. So this is a library that we have created for you to make it easier for you to do data analysis, where we are creating a curated collection of datasets for data analysis and machine learning. And these datasets can be downloaded into Jupyter with a single Python command. This is how it works. We have to install this library, pip install open datasets. So let's just come back to the Jupyter notebook and let us run pip install open datasets. So this is installed the open datasets library. Then we import open datasets as OD. So we just import open datasets as OD. And then all we need to do is run od.download and then pass in a dataset ID. So we have currently added about 6 datasets here, but we will be adding many more. We're trying to make sure that we have at least 100 datasets here by the end of this week. So you will see more here. And we simply need to pick up the ID of the dataset that we want to use. So here we have the Stack Overflow Developer Survey, and we need to paste that ID here. So we just do od.download. And under the hood, this is going to fetch the list of files in the dataset, and it is going to download all the files. So you can see that these URLs have been fetched and they have been downloaded into this folder, Stack Overflow Developer Survey 2020. Okay. So with that, we seem to have the dataset downloaded. Once again, you can go File, Open, and you can check that there is a folder here, Stack Overflow Developer Survey 2020. And this contains the README and then the public file and the schema file. Okay. So those are different ways to download the dataset. The important point is to have the files next to your Jupyter notebook, irrespective of how you get them. All right. So let's just check, import the OS module and verify once again that the dataset is actually downloaded. So when we run os.listdir on the Stack Overflow Developer Survey folder, we see a README, we see some survey results, and we see the survey results public, and we see a survey results schema. So there are 3 files, and you can go through these 3 files. So the README contains some information about the dataset, and then the survey results schema contains a list of questions. And so let's maybe just load up that file and view that file as well. And then there are the survey results public. So this contains the full list of responses to those questions. Okay. So we will load the CSV files using Pandas, and let's import Pandas as PD, and let's use the pd.read CSV function where we will pass in the path to the survey results public.csv file, which contains the survey responses. and we are going to call it survey raw df. So the reason for calling it that is because this is going to be the raw data set, the unprocessed data set that we are loading up, and then we are going to do some modifications to create a prepared data set for analysis. So here we create a survey raw df by calling pd.readcsv, and let's take a look at this. So this is what the data frame looks like. It looks like it has a whole bunch of columns. In fact, in total there are about 61 columns. So 60 of them are each column corresponds to one question from the survey. And here what is not the full question but just a short form. And then there is also one column which contains a respondent ID. So these survey results are anonymized, so there is no personally identifiable information like first name, last name, phone number, email, etc. So results have been anonymized and every respondent has been given an ID, which is not really useful for us. There's one column if you want to use the respondent ID, and then there are 60 columns, one for each question. Now if you want to know what the actual question was, this is where you can use the other file, which is survey results schema.csv, and we'll see that in just a moment. But you can see at the bottom here that there are over 64,000 responses, and as we said, 61 columns. And let's just see a list of columns in the data frame. So we can use survey raw df.columns to see a full list of columns from the data frame. A lot of these may not make sense, so this is where we need to use the schema file to understand what these columns represent. So here we have this file. Let me just put it on a separate line. So here we have this file schema, survey results schema.csv. And maybe let's load up the entire file first. So we can just do pd.readcsv and schema file name. So this file is a CSV file that contains two columns. One of the columns, the first column is titled column. So this corresponds to the names of all these columns except respondent. So main, branch, hobbyist, etc., etc. Actually, it contains the respondent ID as well. So for each of these columns, you can see the actual question here. So for instance, main branch means this question was which of the following options best describes you, etc., etc. Hobbyist means do you code as a hobby? So that's what the correspondence is. Now it's okay to have it in this format, but the schema data frame is primarily going to be used to access the question for each column. So what we might first want to do is we might just want to set the index while loading the file and set the index call argument to this column, so that when we read it, now we just have one proper column and then the column itself is just the index. So now we have the respondent and then we have this one column question text. So now we can access the question text using the respondent as a key, right? So you can, for example, imagine doing .loc and then passing in the respondent key here to access the question text for the respondent. Okay. So now let's simplify it a little bit further. Since we only have one column, we don't really need a data frame. Data frames are required when we want to go over multiple columns of data. So we can simply get the question text out of this, and that will give us a series. Okay, looks like this is stuck. Yeah. So we can just read the CSV file, the data frame, and from it just get the question text column out of it. So that will give us a series, and that is all we need really. The series has an index which is the column name in the main data frame, and then the series has a value. Each value corresponds to the full text of the question. Okay. So that is what we have done here. We've created a schema raw, which is where we read in the schema file with the index column as column, and we just create a series question text. So here is a schema raw, and we can now use schema raw to retrieve the full question text for any column in survey raw df. So now we can check, for example, the years code pro column. So you can see here that years code pro column in the survey data frame corresponds to the question, not including education, how many years have you coded professionally as a part of your work? All right. So with that, we have loaded up our data set and we have converted them into data frames. We have it in a way that we can now work with it using the tools that we know and understand. So we are now ready to move on to the next step of pre-processing and cleaning the data for our analysis. And before we do that, it's always a good idea to keep saving your work from time to time, because we're running this on an online service binder. So we simply select a project name. So here I'm selecting a project name Python EDA Stack Overflow Survey. We install the Jovian library, and then we import Jovian and run jovian.commit. And this is going to ask us, the first time this is going to ask us for an API key, which we can get from our profile, and just paste it in here. And that is going to then commit this notebook to our profile. Yeah, so now this notebook has been committed. So you can view this notebook on your Jovian profile whenever you want to. Wherever you commit from, whether you commit from Binder or you commit from your local computer, everything gets saved on your Jovian profile. And then you can take this and run it on Binder whenever you need it to continue your work. Alright, so moving ahead, now we have our data as data frames, and while this survey contains a wealth of information, it contains about 65,000 responses to 60 questions, we will limit our analysis to a few areas, and this is what you might want to do for your projects as well. Just pick a theme for your project and do not try to do a lot of different things with the dataset. So we will limit our analysis to 3 areas. The first would be understanding the demographics of the survey respondents, who it is that has taken the survey, and the global programming community in general, and understand if the survey responses are representative of the global community. We will also try and understand the distribution of different programming skills, experiences, and preferences. So specifically like things like programming languages, which programming languages do people like, which one do they not? And we will also understand some employment related information, professional and information, preferences and opinions. So something related to the kind of roles people are holding in data science and programming fields. Okay. So to do that, let us select a subset of the columns. So here are some columns for demographics, and then here are some columns for the programming experience, and then here are some columns for the employment. So that you can use the schema that we had created to check the questions. So do check out the full questions for each of these before moving forward. And let us just check how many columns you have selected. So we have selected about 20 columns. Okay. Now, what we will do is we'll take our survey raw data frame, and then if we simply pass in a list of columns to it as an index, that is simply going to select a subset of columns, and then we are going to take that data and just create a copy of it and call that survey data frame. So we are creating a copy so that we can modify this without affecting the original data frame, so that if we make a mistake, we can always recreate this from the original data frame. So we create the survey data frame, and we've just taken the selected columns and created a copy. And then we have created, here we are now going to just pick out the same selected columns out of the schema as well, so that our schema also contains just the columns that we need. So we can look at it right now. So here we have the survey data frame. This now has only 20 columns, the columns that we have selected. It still has all the rows, and then we can check the schema as well. So here we see the schema. So you can see here that the schema has each questions for each of the 20 columns. So you can see in total it has if you check the shape, you will see that it has 20 entries. And the survey data frame has about 64,000 rows and 20 columns. Now we can use the info method of survey data frame to see the list of columns and different data types. So these are all the different columns that we had just selected. And you can see that out of the 64,000 plus entries, not all of the entries are non-empty. So for each of the columns, you see some null values, some values that are empty in the CSV file. So pandas replaces empty values in the CSV file with np.nan, which is a token. It uses for empty values. And because there are so many empty values, and because a lot of rows contain many different types of data, the data type that you see here is detected as object for most of the rows. Now, the object data type is okay while we are working with strings. It's not really a problem. But when we are working with numbers and we want to perform some numeric computations and draw some graphs which involve some kind of number processing, then we might need to convert some of these rows, some of these columns into numeric data types. Okay. So far we have just the age and the work week hours as the numeric data types. If you see age here, it has a data type float 64, and then the work week hours has a data type float 64. But there are a few more columns which can also have a numeric data type. So we have the age first code, we have the years code pro, and we have the years code column. All three of these are also numeric, but for some reason they have gotten classified as object. So let's investigate that a little bit. Now if we just look at surveydf.age first code, and let us look at the unique values for this. So it turns out that most of the values are numbers, and the question, if you're wondering what the question is, let's just check schema.age first code. So the question is, at what age did you write your first line of code or program? And the answers to that are mostly numbers, but there is also an option younger than 5 years and older than 85, which are strings. And we might want to just somehow convert these into numbers or ignore them, because that will keeping them as strings will prevent our analysis. So what you can do, what we will choose to do here is we will choose to replace these with empty values. Okay, and we will choose to convert the rest of these into strings. And the way to do that is to use the pd.toNumeric function. So the pd.toNumeric function, and you can check the documentation, it takes a series or a column and it converts that series into a numeric data, right? So it's going to take all of these and convert these into floats, and wherever it encounters a string, it will throw an error. But what we want to do is we want to ignore the errors and simply replace any non-numeric values with the nan value or the empty placeholder value. So that's why we're passing in errors equals scores. Okay. So this is one thing that we're doing for the age first code. Similarly, we have years code and years code pro. So let's just take a quick look at years code. And years code pro is going to be similar. So years code is including any education. How many years have you been coding in total? And if we take that and we check the unique values of that, so once again, here we have these options like less than 1 year and more than 50 years. Once again, what we are going to do is we are going to ignore those values. We are going to convert these into empty values, and the rest we are going to convert into numbers. So once again, we use pd.toNumeric, and we assign the result back to surveydf years code. So this way we are replacing the columns with a new version of the same column where all the elements are numbers or empty. And then similarly, we have this for the years code pro column. Okay. So go through the other columns and see if there are any other columns that are numeric. But for the time being, we will convert these three into numeric columns. Now, we had two columns earlier, age and work week hours. And then we have three more columns. So in total, we have 5 numeric columns. And we can start seeing some basic statistics about the numeric columns using the describe function. So here we have called surveydf.describe, and you can see that for age, the average age is about 30 of the survey respondents, but the average age of first coding, so the age at which they wrote their first line of code, is around 15. The years of coding is about 12 on average, and so on. Work weeks are around 40. But you will start to notice some problems here. It seems like that the minimum age mentioned is 1, which seems quite unlikely that a 1-year-old infant has filled out this survey. And the maximum age appears to be 279, which once again is quite unlikely. And this is a common issue with real-world data in general and with surveys in particular. You have to understand that surveys are filled by people, and there is no obligation to enter the right information. So sometimes people may intentionally putting the wrong information, while other times there might be accidental errors while filling in. Like maybe somebody was looking to type 17, but they did not press the 7, and so it ended up being 1. Or maybe somebody was trying to type 27 and they accidentally pressed 9 as well, and that ended up with 279. So we should try and solve for these. For each column, you should go through it and try to figure out if the values in the column make sense. And a simple fix in this case would be to simply delete the rows where the value in the age column is higher than 100 years or lower than 10 years. So we are basically saying that those entire responses are invalid. Maybe they're invalid unintentionally, or maybe that was intentional. And to delete the rows, we can use the drop method of the data frame. So we just call surveydf.drop, and then you can just go try and understand the syntax here. What's happening is that we are first checking the list of values surveydf.age where the age is less than 10. So that's going to give us a Boolean series of true and false for each row on whether the age is less than 10 or not. We then use that to select the rows. We then use that to select only those rows where the age is less than 10. And then to drop, to surveydf.drop, we need to pass an index. So if you just call .index on this, so we are basically passing all the IDs of all the rows that need to be dropped. And then we are saying that we are doing this in place. So that is going to remove the rows from this same surveydf data frame and not create a new data frame with the removed rows. There's a lot to unpack here, and the way to solve it would be to just take each expression and run it on a different line, on a different code cell, and see the results and build it step by step. Or you can also follow this link here which explains this entire line of code, or you can just check the documentation of surveydf.drop. Okay, so with that, we've done this for age less than 10, we've removed those rows. Age greater than 100, we've removed those rows as well. And the same holds true for work week hours. So here, if you check the work week hours, it seems like the minimum is 1, which seems reasonable. Some people might be just working for 1 hour a week, but the maximum seems to be 475. And that's probably wrong because the number of hours in a week is about 168. All right. So we can take another approximation here that let us remove all the rows where the value for the column of work week hours is higher than 140 hours, which is about 20 hours per day. So now you have surveydf.drop, and here we are dropping the rows where the work week hours are more than 140. The gender column also allows picking. So there's a gender column. So if you see, there's a column called gender. If we just check schema.gender. So here the question was, which of the following genders describe you? And please check all that apply. So this gender question about gender allows picking multiple options. So here we have man, woman, non-binary, genderqueer, or gender non-conforming. So these are the 3 options. But there are cases where people have picked multiple options too. So for instance, there are around 121 people have picked man and non-binary, genderqueer, or gender non-conforming. Now, while this is acceptable in general, it is going to make our analysis a little bit difficult. So we are just going to do a small simplification here. We are just going to take all of these values where none of the values have been selected, or where multiple values have been selected, or all the values have been selected, and simply replace these with empty values. So the reason we're doing this is that it's going to simplify our analysis just a little bit. So let us simply So what we're going to do is we're going to replace all of these with the empty value. So that's going to simplify our analysis to just looking at one category at a time. Okay. So I'm just going to do this. You can follow this line of code. So we're calling surveydf.where, and surveydf.where takes a condition, and then based on the condition, wherever the condition is satisfied, it replaces the value with a specific value that we are providing here, and you can do it in place. Okay. So I will leave this as an exercise for you to figure out on what exactly this does, but the end result of this is to take surveydf gender, and now when we check the value counts, we only have a single option being selected, man, woman, or non-binary. Okay. And that's just for simplification, not to say that any of these options are invalid. So with that, we have now cleaned up the dataset and prepared it for our analysis. We've made a few assumptions, we've made a few simplifications, we've removed certain rows, we've replaced certain values with empty values, and this is a typical process that you will follow for any dataset, any real-world dataset that you do. The lesson here is not to jump immediately into analysis. Just first go through these values, see where the missing values are, see if you need to do something about the missing values. So for strings, not really, but sometimes for numbers, you may want to do some kind of a replacement for the missing values. Sometimes you may want to simply remove those rows altogether. We've not done that in this case. Deal with any invalid values, any values that you feel are outside any normal range. You should maybe get rid of those rows entirely, or maybe simply clear out those values with just the empty value, and a lot of things like that. And then finally, we've now cleaned up our data frame, so we can just check a sample. So I'm just calling surveydf.sample with 10. So just to see a random sample of 10 rows. And this is again a very good exercise to do. Just go through some sample data from your dataset just to get a sense of what the values in each column and different rows look like. Okay. So here we can see that the countries, it looks like they're strings, and then the age seems to be, okay, seems to be a number. There are also places where people have not filled the age. Then we have the gender. Remember, we've done a simplification here where we've reduced it to just one answer. And then we have the education level. Then there is the undergraduate major and so on. So just going through each columns is going to help you make better inferences on the data. And with that, our data pre-processing and cleaning is complete. So let's just commit our work once again. So moving forward, now before we can ask any interesting questions about the survey responses, it would be helpful for us to understand what the demographics, which is things like the country, age, gender, anything that you can use to pick out groups from the responses, any such information, what the demographics of the respondents look like. And it's important to explore these variables mainly in order to understand how representative the survey is of the worldwide programming community and of the worldwide population in general. And this is again, the reason this is important is because a survey of this scale generally tends to have some bias. So in the world, there are a certain number of people who are programmers. Out of those programmers, a certain fraction use Stack Overflow, and that's not a randomly uniformly selected fraction. So there's already definitely some selection happening there. Out of those who use Stack Overflow, a certain number of people have taken the survey. So once again, that is not a uniform selection from the entire user base of Stack Overflow. There's probably some selection bias here. People who are more likely to take a survey are probably also people who are, let's say, have 3 or 4 other qualities. So it's not a random sample, completely random sample. And then there's also how Stack Overflow publicized the survey, what was the outreach process, and all that decides who saw the survey and who filled the survey. And also like the language of the survey, the kind of questions that were asked, the length of the survey, all of these things make a big difference in terms of who has actually filled the survey. And all this is called selection bias, where the respondents of a survey do not come from a randomly picked sample of the overall population that you want to study. So do keep that in mind, and that's why it's important to first look at the demographics. Okay, so we are going to do what is called exploratory analysis and visualization, where we don't really have a question in mind. We are simply looking at different rows, columns, comparing things, plotting graphs. And since we will be plotting graphs, we will be using matplotlib and Seaborn. So here what I'm doing is I am importing matplotlib and Seaborn, and I've set some basic styles. Like I've used the dark grid style from Seaborn. I have increased the font size and the figure size for matplotlib so that we can see the figures a little more easily. Now if you want to understand what all of these mean, I will refer you back to the previous lecture on data visualization with matplotlib and Seaborn. Okay, so with the imports out of the way, so let's first look at the number of countries from which there are responses in the survey, and maybe plot the 10 countries with the highest number of responses. So there was a question, where do you live? And so the column name for that was country. So we just see that from the schema, country corresponds to where do you live. And from the survey data frame, if we just get the country column and then call .n_unique on it, so that's going to give us the number of countries that are there in this data set. So respondents from 183 countries have answered questions, and that's pretty good. It's quite wide, but it might be better to look at what the distribution of responses across countries looks like. Now we cannot plot the entire distribution for 183 countries. So maybe what we'll do is we will simply look at the top 15 countries from where we had the maximum responses. And the way to do that is to take the surveydf.country, the column, and then use .value counts on it. So .value counts is going to, well, let's see what that does. So you can see here .value counts. That's going to take each distinct value on country, so each unique value inside country, and then take that and count the number of values for each one. So here you can see that these are the different value counts. So for each country, we now get back a count. and this is a series essentially. And then from that, and this is going to be sorted, so you can also decide whether you want this to be sorted. So you can set sort equals true, and you can set ascending equals false. By the way, if you want to show this documentation in line for any function that you're using, all you need to do is press Shift plus Tab. So here I'm pressing Shift plus Tab, and that shows me the documentation. Okay, so we have the value counts, and then we pick the top 15 countries out of it. So those are the top countries. You can see here United States at the top, then India, then UK. And it's good to look at it this way as a table, but you cannot really grasp what is the difference visually, what is the distribution looking like, and that is where a bar chart will probably help. So we can use the index of the series as the x-axis, and then we can use the values in this series as the y-axis. So we're going to create a figure here. So I'm just going to set a plt.figure fig size, just to make this a big figure. We're going to set a title for it. So we're going to set the title as the question that was asked. And then we're going to use cbon.barplot. So cbon has been imported as SNS, and we use the bar plot. And for the bar plot, we give an x-axis and a y-axis. So the x-axis, we are going to use the index, the names of the countries. And for the y-axis, we are going to use the values, which is the number of respondents from each of these countries. So there you go. Now you have the graph. Now, before we analyze this, I just want to say, by default, these labels are printed horizontally, and if we do print them horizontally, there will be a lot of overlap. What we've done here is we've called the plt.xsticks function, and we've set rotation to 75. So that has taken these labels and then rotated at 75 degrees. And because of this, now you can see that they're slightly slanted and we can all read them. Okay, so now we have the graph. So looking at the graph, it seems like a disproportionately high number of responses came from United States and India, right? So the United States has 12,000 responses, and then India has 8,000, which is about only about 75% of the number of responses from the US. And then next is United Kingdom, which is less than half of India. And that already tells you that probably this survey is not really representative of programmers around the world. Maybe a large 12,000 plus 8,000 plus 4,000, so that's about 24,000 out of 65. So that's about more than 1/3, more than 40% of the responses have come from these 3 or 4 countries. And you might, if you think about this a little bit, it makes sense because one, this survey is in English, so it was only conducted in English, so therefore the programmers from non-English speaking countries probably did not get to hear of it. Second, Stack Overflow's user base Stack Overflow is also a platform that is completely in English. So its user base is primarily from countries where English is spoken in different professions. And those happen to be the top 3 countries, United States, India, and United Kingdom, where we speak English on a day-to-day basis in our professional lives. Okay. So that's something to consider, that the survey may not be representative of the entire programming community, especially the non-English speaking countries. And it's something for Stack Overflow to consider. Maybe they should try translating their question and answers into different languages, and maybe they should also translate their survey into different languages so that they can get a more representative result. Okay. Now there's an exercise for you here. What you can do is you can try finding the percentage of responses from English speaking versus non-English speaking countries. So here I've linked to a list, a CSV file which contains the list of languages spoken in different countries. See if you can combine that data with this data to create a new column that says English speaking, and maybe it contains yes or no or true or false for the English speaking column. And then see if you can see how many responses are from English speaking and how many are not. Okay, so that was about the different countries the data came from. Probably the next thing that we can study is the distribution of the age of the respondents. So the age is another important factor to look at, and this time, because age is numeric, we can probably use a histogram to visualize it. So we are going to use plt.hist, and let's check what the question about age was. So the question was, what is your age in years? And a lot of people may have preferred not to answer this question. Fortunately, what happens is when we use these matplotlib and cbon functions, any empty values are automatically ignored. So now we have So we are calling plt.hist, and then to it we are passing the surveydf.age. So this is the column containing the age values, and these are all numeric, remember. So then we are also going to set a number of bins. So what we want is we want to take the ages starting from 10, because we've removed everything below age 10. So we want to start from 10 and we want to go up to 80. You could also go up to 100 if you wish. Let's maybe change that to 100. And we are going to split this entire range of 10 to 100 years into ranges of 5 years. You could split this into ranges of 10 years as well, but we'll split it into 10 years. And then we will count the number of responses in each age group. Okay, so this is what the chart looks like. So it seems like that there are very few responses below 15 years of age, and a little over 2,000 above 15 years of age. But the maximum bulk of the responses seem to be in the range of 20 to 45 years. Maybe you could say 15 to 50 years. So that seems to be the sort of the professional lifespan of a programmer to a large extent. But on the other hand, you can still see thousands of responses beyond the age of 45 and 50. It's common that a lot of people tend to fall into this age range of 20 to 50, but on the other hand, you have people from all over, all the way going up to close to even 80 years of age. Okay, so that's good. Now we understand the distribution of age, and roughly this is representative of the programming community in general, especially since a lot of young people have taken up computer science as a field of study or a profession in the last 20 years, right? Colleges now have computer science degrees. The number of jobs in computer science have increased, and most new jobs tend to be taken by younger people, and most new degrees as well. So that's why it is slightly representative, and you can do some research on how exactly representative it is and which age groups are left out. And here's an exercise for you. You may also want to just create specific age groups like 10 to 18 years, 18 to 30 years, 30 to 45, 45 to 60, and so on. And you may want to create a column called age group, which will contain, based on the age, it will contain one of these values. And then what you can do is you can repeat the analysis in the rest of this notebook for each age group. If you just want to pick out your age group, let's say you're in the 30 to 45 age group, and you just want to know what programmers in your age group think, then you can just do this analysis for your age group, and that will be an interesting thing to try out. That's a project idea right there. Then let's look at the distribution of gender. We've already done a small simplification here where we've excluded multiple responses. And now it's a well-known fact that women and non-binary genders are underrepresented in the programming community. So we might expect to see a skewed distribution here. If we do schema.gender, here it looks like the question that was asked was, which of the following describe you, if any? So people were open to leaving it blank. And then we have the gender counts. So now we are taking surveydf.gender and then using value counts here. And already you can see that there is a huge drop. There are 45,000 responses from where people have selected man as the gender, and there are about 3,800, only 3,800 values where people have selected woman. And let's also include in value counts, you can also include drop any equal to false. What that does is that also tells you how many people have picked nothing, no value. So now what we can do is we can use a pie chart to visualize this distribution. So once again, we take these gender counts and we use plt.py, and we can then give it an index. We can give them some labels as well, and we can give the chart a title. So here you go. Now it seems like around 71% people have picked man, only about 6% have picked woman, and only about 0.6% have picked non-binary, genderqueer or gender non-conforming. And if we exclude the NaN values, so if we exclude the no answers, so among the people who have answered, it seems like 92%, close over 91% are men. And this number is actually, so that means only about 8% are women or non-binary, and this number is actually a far more skewed than the overall percentage. So the overall percentage of women and non-binary genders in the programming community is estimated to be about 12%. So this number still has some skew. And what this number tells us in general, and even the overall figure, is that there is a diversity problem in the programming community, that we definitely, if 50% of all people are women, and then there's a larger number, I think, I'm not sure about the number, but a larger percentage of people also identify as one of the non-binary genders. So we definitely need to have more representation in the programming community, and we should support people from underrepresented communities and encourage them to be part of the programming community. Okay, and an interesting exercise for you now to do would be to compare the survey responses and preferences across genders and repeat this analysis with those breakdowns. So for each graph, maybe instead of for each bar chart, try to show side by side men versus women and see how things differ. So for instance, you could try and figure out how do the relative education levels differ across genders. Do women hold similar degrees in terms of percentage, or do they hold higher degrees? And you may be surprised. How do the salaries differ? That is another thing to figure out. We definitely know that there is a gender pay divide, there is a gender pay gap. So maybe you can discover that, and there's a column which talks about salaries. And then you may find there's this analysis on gender divide in data science, and you may find that useful. That is also an exploratory data analysis project, if you want to explore that a little bit. So that was about gender. Now let's talk about the education level. Now, formal education in computer science is often considered an important requirement of becoming a programmer. Computer science is one of the most sought after degrees, and both in bachelor's and in master's. Let's see if this is indeed the case, because on the other hand, a lot of you may have learned programming on your own, and there are many free resources and tutorials available online to learn programming. So what we'll do is we will use a horizontal bar chart to compare the education levels of different respondents. So you can just check here schema.education level. So there's an ed level column. The question was, which of the following describes the highest level of formal education that you've completed? So keep that in mind, this is the highest level. So what we're going to use now is a count plot. So what's a count plot? We can check the documentation. So the count plot shows the counts of observation in each categorical bin using bars. So what that means is, if you check the different values that education level contains, so if we just check if we just check survey df dot ed level dot, let's say what are the unique values. So these are all the unique values, and the count plot is going to tell us for each of these values how many observations are there, like how many times was this particular option picked, or how many times does this particular value show up in that column. Okay, so we pass to count plot survey df.education level, and you can just do this, but that is going to make vertical bars, and if you just want horizontal bars, you can just pass y equals survey df.education level. So this is what the graph looks like. Maybe we should increase the size of the figure a little bit. So let's just set plt.figure fig size. Okay, this is a lot better. So the question is, which of the following describes the highest level of formal education you've completed? And now you can see here that it seems like out of the 65,000 respondents, about 25,000, over 25,000 hold a bachelor's degree, and then another close to 12,000 hold a master's degree, and then there are a few more which hold a doctoral degree, probably about 1,500 or so. So all of these three combined, it seems over half of the respondents hold a bachelor's or master's degree. So most programmers definitely seem to have some college education, definitely maybe some STEM education, what is called some kind of a STEM education. But it's not clear from just this graph alone whether they hold a degree in computer science. Okay, so let's dig a little bit deeper into that. And one problem with this graph is that here we are showing the absolute numbers, and probably what we really want to understand is percentages. So one exercise for you is to convert this graph to just show percentages instead of the full numbers. Okay, and that will probably give a clearer idea, because we probably want to know, out of the number of people who have responded to this question, what percentage have mentioned that the bachelor's degree is the highest degree that they hold. And that is probably the more relevant question to ask. So you can try and modify this code to just show percentages. Okay, but keeping that aside, we could tell that over half of the respondents hold a master's or a bachelor's degree. Alright, so now let us then take and plot the undergraduate majors. So this time we will look at schema.undergrad major, which was what was your primary field of study. And we will then convert these numbers into percentages. So to convert these into percentages, we take the value counts for each of the values. So here we say surveydf.undergrad major.value counts. So for each major, like computer science major, you have 31,000 responses and so on. So what we can do is we can divide that by the total number of responses given for undergraduate majors. So let's just take the survey df.undergraduate major and call .count on it. So .count is going to count the total number of null values. So if we do that, then you can see that now we get back a fraction. So for each major that was provided here, we get back a fraction, 0.61 and so on. And if we multiply that by 100, we are going to get back a number, or we're going to get back a percentage. All right. So now we have a 61% have computer science, and another 9.3% have picked another engineering discipline, and so on. All right. But it's probably better to look at that using a graph. So we just put this result into a variable called undergraduate percent, and then use sns.barplot to plot it. Okay, so now here we have it. So in terms of the primary field of study, it seems like out of the people who have responded, over 60% say that computer science or software engineering or computer engineering was their major. Now, the one way to know this is like a glass half full, half empty kind of a situation. The way I would interpret this is that close to 40% of programmers holding a college degree have a field of study other than computer science, which is very encouraging. A lot of people after college feel that you cannot switch your field. That is definitely not true for computer science. If you want to get into computer science and you have some sort of formal education, some sort of STEM education, you can absolutely pursue it. There are so many online resources, like close to 40% of people who are in the domain are from streams other than computer science. So I think this is a very encouraging sign, and I think this number is only going to go higher because there are better and better resources available, and programming is proliferating into pretty much every domain now. So you do a little bit of programming no matter what you study, and that equips you to become a programmer as well. Even data science, for example, is primarily a lot of programming. So what we understand in general is that while college education is helpful in general, you do not need to pursue a major in computer science to become a successful programmer. And one trend that you might have noticed here while we are doing exploratory analysis is that first, every time we plot some graph, there is some background to it. There is a reason why we are exploring a particular column. And this is something that we've explained here, that we want to understand, like the reason we are looking at education level is to understand whether formal education is important or not. So have some background, have something in mind when you are exploring a particular column. And then once you have explored that column, once you have plotted a graph, try to gain some insight from it, try to make some kind of an inference or an observation or a hypothesis based on it. Sometimes you may need to then go do more research to identify if your hypothesis is correct. And in other cases, the inferences can become pretty clear. For instance, in this case, it is pretty clear that a lot of people do not have a computer science degree. All right. And that is the best part of exploratory analysis, is that you get to form all of these interesting inferences. Each time you draw a graph, you learn something new. Each time you look at a column, you learn something new. And then there's an exercise here for you. There's a column called new ed IMPT. Let's see what that column is. So that's, let's see, schema.new ed. Okay, so that column is, the question in the column is, how important is a formal education such as a university degree in computer science to your career? So now what you can do is you can take this column and analyze the responses, the distribution of responses for people who hold some college degree for people who hold a computer science degree versus those who do not. Okay, try and analyze these results. So what percentage of people who hold a computer science degree have selected that formal education in computer science is important to the career, and what percentage of people who do not hold a computer science degree have selected that formal education is important for their career, and see if you notice any difference in opinion. My guess is somebody who holds a college degree may value it highly, but somebody who does not hold a college degree will still become a programmer will probably say that it's probably not that important. So do check it out, do discover there are more insights to be gained here. And then one last area that we will look at is employment. Now, especially among programmers, freelancing, contract work and part-time work is slowly becoming a more popular choice. So it would be interesting to see the breakdown between full-time, part-time and freelance work. So maybe let's visualize the data from the employment column. So the employment column was which of the following best describes your current employment status. And what we've taken here is, once again, we are going to plot a simple horizontal bar chart. And one of the things that I want you to take away from this is also that simple charts are often good enough for a good analysis. You do not have to come up with a lot of fancy charts, although it's good if you can find the best chart for the best kind of graph for every statement, for every situation. But even simple bar charts, line graphs, scatter plots can give you a lot of information. Right? So you're very well equipped at this point if you've worked through this course. So now we look at the surveydf.employment.value counts, and we are just setting normalize equals true. So when we set normalize equals true, that also gives percentages, and then we're also going to convert sorted in ascending order and convert that, multiply by 100 to get percentages. So normalize gives fractions, and then we convert that into percentages. And then we use the pandas plotting function, so dot plot, and so it's just to show you a variation of different ways of plotting. And we are going to plot a horizontal bar chart with the green color. So now you see that among the people who have replied to this question, employed full-time seems to be about 70%. So 70% people are employed full-time among the respondents, but there are a fair number of students as well. So there are about 12% of students. What you might want to do is you might want to break down, and then there are people who are not employed but are looking for work, and then there are people who are freelancers, part-timers, and then there are people who are just, maybe their hobbies, they're not really looking for work, they're not employed, or they're retired. So you might want to create a new column, employment type, that contains values like enthusiast, which could mean students or people who are not employed but are looking for work, and then professional, which is people who are employed full-time, part-time, or are freelancing, and then other, which is people who are not employed or retired. And then what you can do is you can see for each of these graphs, how do the preferences differ between students and professionals, between enthusiasts and professionals, right? Especially some of the things that we'll do after this, which is analyzing programming language preferences and things like that. So that's a good exercise to do. In any survey, in any analysis, all of these breakdowns offer a lot of insights, and the best way to do it is identify which group you lie in. Let's say you are parsing by gender or by age or by your employment status, and then do the analysis just for yourself and people like yourself, and that is going to give you a lot more insight. Okay. Now, one interesting observation here is that if you take away students, then among people who are employed, it seems like at least 10% of the people are working independently as contractors or freelancers or self-employed. For instance, startup people who are doing startups or running their own companies. And that is pretty encouraging. That's a pretty high number for a technical field like this, to be able to work on your own without being formally associated with any company. So that's a great thing, that it's also a way for you to try and break into the field. If you are looking to become a programmer or looking to break into data science, maybe initially you can try some freelance work, you can try maybe an internship, some part-time work, and that can help you transition into a full-time role. So that's something to consider as well. Now, in terms of what are the actual roles held by the respondents, we can look at the dev type field. So you can see here there's a dev type, which of the following describes you, and there are a bunch of different values for the roles that are provided. Now the problem here is that this allows selection of multiple values. So if you just check the dev type.value counts, or let's just do dev type.unique, you will see here that there are a lot of different possibilities. So you can see here that there is a developer, desktop, and okay, let's just try value counts. That's probably a little bit easier. Yeah. So you can see here that there are some So simple options that were picked, like developer full stack, just that, and then developer backend. But then there is also, you can select multiple options. So you can select developer backend, and the semicolon indicates that multiple options were picked. So about 3,000 people have picked 3 options: developer backend, developer frontend, and developer full stack. And about 2,000 have picked developer backend and developer full stack. And then there are a lot of people who have picked many different combinations. So it's not really clear even from the data how many options were available, but it seems like this person has picked a whole bunch of different options, and so is this person, and so on. So this is where we might need to do some more processing. Now we might need to take this column, which contains a list of values separated by semicolons, and maybe split it out into multiple columns. Okay, and for that, what we are going to do is we are going to define a helper function called split multi-column that is going to take a series or a column of data which contains list-like values, lists of values. So data like a column like survey.dev type, and split the values of that column into multiple columns. Okay. Now I will not go over the code here, and you can try this. You can try to run each line one by one, and you can try to understand the code. So by this point, I hope that you are well equipped to understand this code. Just run each line on a different cell. If you're not, you can also ask on the forum, and you can have a discussion where you can ask, you can share where you're stuck or which part you don't understand, and you can have a discussion to figure it out. But let us look at the output. So we know what the input into this looks like. So the input into this split multi-column function is going to be a series where people have picked either none, or one or more than one options for their employment type, for their role, job role. So we can call split multi-columns on survey.dev type, and passing this column returns a data frame. So we get back a data frame dev type df, and if we just check this data frame, it seems like this data frame now has one column for each of the options that were provided for the question. So now we have one column for developer, desktop or enterprise applications. Then we have developer full stack, developer mobile, designer, and so on. So there are in total 23 columns. So there are about 23 options that were given for your job role. And what we have is for each respondent, we have either true or false. So for instance, for this respondent has not selected developer desktop or enterprise, but this respondent has selected developer full stack, and this respondent has selected developer mobile, and they have not selected developer frontend or backend. All right. So this is how sometimes we might need to do a little more processing of our data. We might need to break one column into an entire data frame so that we can do our analysis. And now that we have this data frame, the dev type df, we can now use this to identify what were the most common roles. Okay. And a simple way to do that would be to simply count the number of trues in each column. And you know that true when it is converted to an integer becomes 1, and false when it is converted to a number becomes 0. So what we can do is we can simply take the column wise sums. So we can just take dev type dot sum. So now we get a column wise sum, and then we can sort those values in a descending order. So that's going to give us these dev type totals. So now you see that we have developer backend, developer full stack, developer frontend, and so on. So those seem to be the most common roles. And it's not surprising that the Stack Overflow is primarily a tool used by developers and professional developers for finding answers to small questions on writing code. So it's not uncommon that the developer role that you see is the most common one. But one interesting thing for you to figure out would be what percentage of respondents work in roles related to data science. And then you can probably also try and figure out which role has the highest percentage of women. So what you can do is you can just filter. Now that you have this data frame, you can then merge it back into the original data frame. So you can create a new merged data frame which contains the columns from survey df, but also contains these columns for each role. And then you can try and find out which role has the maximum percentage of women. Okay, that's an interesting thing to figure out. So with that, we end our exploratory analysis, and we've only explored a handful of columns from the 20 columns that we selected. We've only explored about 5 or 6. So you can explore and visualize the remaining columns. Here you have some empty cells, and you can always add new cells using insert cell below. So please do that. The more you explore, the more you learn. It's possible that while you work through this notebook, you find 5 or 10 interesting columns and you just want to do a project using those columns. And that's perfectly acceptable. You can use this data set for your project. Just do not repeat the same analysis that is done here. Do something a little more interesting. And before we continue, let us upload our work. So from time to time, keep running jovian.commit so that you do not lose your work. Alright, so now we come to a slightly more interesting part, although I think the exploratory analysis was pretty interesting as well. But now we can ask some questions and then answer them. So we've already gained several insights about the respondents and about the programming community in general, simply by exploring individual columns. But let's ask some specific questions and try to answer them using the data frame operations and using interesting visualizations. Okay. So the first question that we'll ask is, what were the most popular programming languages in 2020? So this survey was conducted in February of 2020. So this is technically 2019's data. But see, so we see schema.languages worked with. So the question asked was, which programming, scripting and markup language have you done extensive development work over the past year, right? So which languages have you used in the past year? But this is a two-part question, and the second part is, and which do you want to work in over the next year? So here, the respondents were presented with a list of options, and then for each option, they had 2 checkboxes. So the first checkbox they would tick for this part, whether they've worked with it in the past year, and the next checkbox they would tick for this part, whether they want to work on it over the next year. And the responses were then taken and they were broken into two columns. So we have the language worked with, which contains the answer to the first part, which language have you worked with in the past year, but then we also have the language desired next year, which has the exact same question, but this contains responses to the second part. So I'm showing you this because this is something interesting that with real world data, and especially with how surveys are conducted, you might often have this, and without the context, you might not understand what's the difference here, because it seems like languages worked with and languages desired next year have the exact same question. So you may want to just go through the README, or you may want to take the survey yourself to understand that, okay, there are 2 parts and the first part is covered in the first column and the second part is covered in the second. Okay. So putting that aside, let's just look at what some values in the languages worked with column look like. So it looks like, once again, people could select multiple options, multiple languages. So you can see that the first person has selected C# and then HTML, CSS and then JavaScript. So they are separated by a semicolon. So this is similar to the dev type field. So the first thing that we might want to do is just split this into a multi-column. So we just call split multi-column on surveydf.languages worked with. And then we can see the languages worked df. So this is now the data frame where we have 25 columns. So it seems like 25 languages were presented to the respondents. And now for each of those, for each respondent, we can see true, false. So true indicating whether that respondent has used the language, and false indicating whether they have not. Okay. So now going back to the question, what were the most popular programming languages in 2020? So what we can do is we can try and identify percentages, what percentage of people have selected JavaScript, and then what percentage of people have selected Swift and Python and so on, and then plot that as a bar chart. Okay. So once again, to get these percentages, we simply say languages worked df.mean. So this is another way to do it, because true becomes 1 and false becomes 0. So if we take the mean of this entire column, if we take a column-wise mean, we get back the percent or the fraction of true values in the column. So the mean is simply sum of all the values divided by the total number of values. So since the zeros or the falses go away, that is basically the number of true values divided by the total number of values. And that is essentially the percentage of true, right? So we take, or the fraction of true. So to convert the fraction into a percentage, we multiply by 100, and then we sort values in descending order. So that gives us the percentages of each language. So it seems like JavaScript is the most popular language, followed by HTML, CSS, and SQL, and so on. And let's visualize this. once again using a horizontal bar chart. So now it seems like the languages used in the past year, once again, JavaScript was the most popular language, followed by HTML, CSS, and this is no surprise because today a lot of software has moved onto the web. Like you probably spend most of your time in the browser. Even the Jupyter Notebook platform that we're using is actually running in the browser. And the only way to write code in the browser is, one, you have to write HTML, CSS, and second, you have to write JavaScript for interactivity. Now, JavaScript might be higher than HTML, CSS because you can also use JavaScript on the server side using a framework called Node.js. And because of all these reasons, JavaScript is the most popular language because it is the de facto language of the web. And then we have, so again, now we have plotted this chart, and based on this chart, we can make some inferences, right? Then we have SQL. Now, once again, today, all applications need some kind of a database, and the most popular form of database is what's called a relational database, or what is called a tabular database. So a lot of the data, let's say the data of your Facebook accounts, the data of your Twitter, the data of your Instagram, or any platform that you use, the data that you put into Jovian, a lot of the data is saved in SQL databases. And the way to interact with these databases using the SQL language, and that is why SQL is probably pretty popular as well. But beyond that, if you take away web development and take away database access, the actual application development, or like any backend application development or data science, a lot of these other areas, any non-web related development, seems like Python is the most popular language. And this is again no surprise because Python is a general purpose language and it has beaten out Java. So Java was the de facto language for all development pretty much for about 20 years, but it seems like Python has now beaten out Java. So it's a good thing that you're learning Python. It is definitely an in-demand language. Okay. And there is a whole wealth of information that you can gather just from exploring a little bit deeper into this question. For example, what are the most common languages used by students? And how does the list compare with the most common languages used by professional developers? So is there a gap between what students learn and what professional developers use? You might want to answer what are the most common languages among respondents who do not describe themselves as front-end developers. Because front-end development, you don't really have a choice. You have to use JavaScript. TypeScript is a choice, but it's a small choice. So if you just exclude front-end developers, can you then answer what are the most common languages people use? Can you try and find out what are the most common languages used by respondents who are working in a field related to data science? And maybe also see in terms of age, developers who are older than 35 years of age, or maybe developers who have more than 10 years of programming experience, what are the most common languages used by them? And what are the most common languages used by people who are younger? Do you see a shifting trend? And what are the most common languages used in your home country? That is something that you can try and find out because there are responses from over 180 countries here. Is there a difference between, let's say, US and India and China and different countries? Then moving ahead, another similar question we could ask is, which languages are people most interested to learn over the next year? So for this, we can use the language desire next year column, which will have pretty much identical processing. So we take the language desire next year and we split it into multi-columns. Then we get percentages for each language once again by taking the mean and sorting the values and multiplying by 100. So you can see here the language interested percentages. These are the values. And let us just jump into visualization directly. The visualization is once again pretty much identical. And it seems like that Python is the language that most people are interested in learning. So we have Python, JavaScript, HTML, CSS. Again, they seem to be close by, and followed by SQL and TypeScript. And it's no surprise that Python is the most sought after language because it's an easy to learn general purpose programming language, and it is very well suited for a variety of domains like application development, numerical computing, data analysis, and so on. And in fact, we're using Python for this very analysis. So you are in good company. If you're learning Python, you can apply it to a whole host of different domains. What you can do is now you can repeat the same exercises that we discussed for the most common languages. Just replace all of these questions with the languages people are most interested in. So those are some exercises. And you can also, the next question what we'll do is we'll combine these two things. So the question here is, which are the most loved languages That is, where do you see a higher percentage of people who have used the language and want to continue learning it over the next year? Okay, so this may seem like a somewhat complicated question to ask. Okay, people who have used the language in the past year and they also want to continue learning it, how am I going to figure that out? It may seem a little bit tricky, but it's actually really easy to solve using pandas data frame operations. So here's what we'll do. We will create a new data frame, languages love df, which has the same structure as languages work df and languages interested df. So again, for every language it has a column, and then for every respondent there is a row, and there is a true value only if the corresponding value in both languages work df and languages interested df are both true, right? If somebody has worked in that language in the past year and wants to continue using that language, then we are going to put in a true there. And the way to do that, it's really simple. All you do is you take the languages work df and then you put in an ampersand, and then you pass languages interested df. What this will do is this will do a element wise AND, right? A Boolean AND. So if two values are true, two respective values, then you will get 2. And if you have a true and a false, or a false and a true, or a false and a false, you will get back false. Alright, except that this is going to happen on a per element or a per value level. So now we take languages love df and then we look at it. So for example, this respondent has true set for C# because this person has worked in C# and they are interested in continuing to work in C#. So that's we are saying that this is a proxy for saying that they love this language. Okay, so let's convert that into percentages. Now we want to take these numbers, and for each language we want to identify how many people love it out of the number of people who have used it in the past year. So we take language loved.sum, and then so that's a column wise sum, and we divide each of the column wise sums by languages worked.sum. So for the column C#, we will count how many people love the language, so how many trues there are in this column, divided by how many people have used the language. And then we are also going to multiply it by 100 to convert it into a percentage, and we are going to sort it in a descending order. And let's take a look at that. So you can see here that we have languages loved percentages. You can see that for each language we now have percentages, and you can see who the winner is here. So the winner seems to be a language called Rust, and let us look at it in a plot. So the winner seems to be this language called Rust. You may not have heard of it, but it is a low-level language for doing systems programming, and it provides the performance of languages like C++, but it provides many conveniences and a type system of some of the best languages, things like Scala and Java and so on. So it's a pretty useful language. A lot of people enjoy using it, and it's interesting to see that a small language with a growing community is one of the most loved languages. And in fact, you can see the hints here. Now, if you see this graph, Rust seems to be used in a very small fraction. So you see Rust here, it's a small fraction of people who use it. It's far smaller than, let's say, JavaScript. But if you look at this graph in terms of people interested in using or learning Rust, it is way up ahead, somewhere at the top, almost close to about a third or maybe higher than a third of JavaScript. So it definitely seems to be a language that's gaining a lot of popularity and a lot of interest. So maybe if you're looking for a new language to learn, Rust may be a good choice. And this metric that we just calculated is something Stack Overflow calculates every year based on their survey results. And Rust has been Stack Overflow's most loved languages for 4 years in a row, followed by TypeScript. And TypeScript again is a language that offers an alternative for web development. So these are things that you should do. And once you get an answer, once you get a graph, maybe just search online on why the result might be such, so you can learn a little more about Rust and TypeScript. Now, what I find probably even more interesting is that Python features at number 3, despite already being such a widely used language. And that's generally not true for widely used languages. If you see JavaScript, in terms of the love score, it's fairly low, and Java is far lower. Whereas Python has remained at number 3, right? So it seems like people who use Python enjoy Python, and that is because the language has a solid foundation and it is really easy to learn and use. I hope you've been able to learn Python. You can now say that you're comfortable with Python in just these 6 weeks. And then it has a strong ecosystem of libraries for various domains, and it has a massive worldwide community of developers, and that now includes you and me, so who enjoy using it. So I've been using Python for the last 12 years. I definitely want to continue using it for the next 12 as well. And I hope you feel the same way. So that's about the most loved languages. We now have some insights about that. The next simple exercise that you can try here is to identify the most dreaded languages, which is languages which people have used in the past year, but do not want to learn or use over the next year. There's a small hint here. What you can do is you can simply invert the language's interested data frame. So and the way to invert it is using this tilde operator. So just invert that data frame and then do the same thing that we did here. So you should be able to answer the most dreaded language, and then see if your results, you get the same result as what the Stack Overflow results present. So you can always refer to them. So moving further along, next question here is, in which countries do developers work the highest number of hours per week? Okay. Now, to do this question, we will need to use the group by function of a data frame, the group by method. And there's a small caveat here. We only want to consider countries with more than 250 responses, because otherwise it's not really representing an average, because there are definitely lots of countries with thousands of responses, and we are setting a threshold of 250 so that if there's a country where only 10 people have responded, we're not going to consider it in terms of to get the average number of hours per week. So we take DF and we group it by country. So what this does is it takes for each value of country, and there are 184 values. We take all the rows which have that country related to that country and then separate them out into groups. And so far we've not performed any operation, so you don't see any result here. Now for each of these rows, the column that we are interested in is work week hours. So we select the column work week hours, just as we select the columns of our data frame. And just as an example, let's select the age column as well. So now once again, for each of the groups, we have all the rows, and from these rows, we've only selected the work week and age columns. And now we need to aggregate them. So one way to aggregate them could be using a mean. So if we use a mean, then we can see here that work week hours and age. So we will get back a new data frame where now the index is the name of the countries, all the different unique values in countries. And then the values for work week hour and age are the averages from those groups. So all the rows from Afghanistan, we've taken an average of the work week hours and put that value here. Similarly, all the groups from Afghanistan, we've taken the age, and all the rows from Afghanistan, we've taken the age and we've put in the average value here. Okay. So this is how you group by, and you can learn more about this in the pandas lecture, which is lesson 4. Now what we want to do though, is we want to only look at countries which have more than 250 responses. So the way we're going to do that is, first we're going to create a countries data frame. And this is exactly what we just did, group by country, but just keep the work week hours and take the mean and then sort to aggregate and then sort by work week hours in a descending order. So that's a country DF. Okay, so you can see that these are the countries with the highest, these are countries with the lowest, but it's possible that a lot of these countries, probably the number of responses is really low. So what we will do is we will create a new data frame called high countries DF, where we will take where we will only select the rows where the value counts are greater than 250. So we are getting surveydf.country, and we are trying to find the value counts of each country, the number of responses from each country, and then we are filtering out those only where the responses are greater than 250. And then we use the .loc.loc function to pick values from the countries DF with only value counts greater than 250, and then we pick the top 15 out of those. So let's see now. So now we have the top 15 countries. Okay. And once again, if you do not understand this, there are a couple of things you can do. Revise the pandas lecture. That's one thing you could do. Look at the documentation of countries of .loc, and split this into small parts. So first take this surveydf.country.value counts, run it in a cell. Take that and compare that with 250 and see what the result of that is. And then put that into countriesdf.loc and see what the result of that is. And then add in the head. So with all of these things, it's a question of breaking them down step by step. And then the more you break them down, the more you understand and the more you will be able to use them. So now we have the high response countries. And these are the 15 countries with the highest number of working hours. It seems like some South Asian countries, some Asian countries like Iran, Israel and China have the highest working hours, which is followed by United States. So that's interesting. And then we have Greece. So people are probably working a lot, programmers are working a lot in Greece. And once again, we see a bunch of Asian countries all the way till, actually a majority of these seem to be Asian countries. And then there are a few European countries and then there is United States. But overall, there isn't too much variation. If you see 44 is the highest value. If you just take the first three as outliers, then here you have 41 to 40. So on average, there are only about people are working at about 40 hours per week. There's no variation where there's a country with an average of 60 hours or a country with an average of 20 hours. At least it seems so from the top 15. So now a few exercises that you can try is try to compare how the average working hours compare across different continents. So you may find this list of countries in each continent useful. Try and find out which role has the average number of has the highest average number of hours worked per week out of all the developer or out of all the roles that we looked at. So you may need to merge with the dev type data frame that we created, which had one column for each role, and try to find out maybe how the hours work compare between freelancers and developers working full-time. Well, full-time developers, it's possible that you might find that the average is around 40. But freelancers, one of the reasons people take up freelance or even part-time work is because they want free time to work on other things. So let's try and verify if this is true. Do freelancers work less or more? And that could help you maybe even decide if you want to choose between a freelance or a full-time role. Okay. And then let's ask one more question. How important is it to start young to build a career in programming? Okay. And this is again something that is a question that a lot of people wonder, not just about programming, probably about data science and in general about any field. Can you enter this field, let's say beyond, if you've not done it in college? And I think we've established that even if you've not taken it in college, you can still enter the field. But can you enter the field if you've worked in a different domain for a few years? Can you enter this field in your 30s, in your 40s and so on? Okay. So what we'll do to answer this question is we will create a scatter plot of age versus the years of coding experience. So there is years code pro is asking, not including education, how many years have you coded professionally as a part of your work? Okay. So what we'll do is we'll plot age on one axis, on the x-axis, and then we'll plot the years of professional coding experience on the y-axis, and that should maybe give us a hint. So here is a chart. And this is what it looks like. Now, if you look at this, it seems, let's look at some values and let's try to understand this chart. And we've also put in colors here and we'll touch that in just a moment. But if you see here in let's say you're looking at age 40. So at age 40, there are several people who have less than 10 years of programming experience. And there are even, so at every age, all the way from around 15 to even close to 50, there are people who have just started working as programmers. So what that means is that you can start programming professionally at any age. There's no restriction that you have to start early. People are starting in their 20s, in their 30s, in their 40s, and everybody is welcome. And this is professional experience. This is not just programming experience in general. So you can, if you put in the work, if you learn, if you're open to learning, if you're excited about it, then you can definitely get into the domain. And then we have also added a color for each of these dots. So each dot represents one response. So we've added colors. So the color we've added is If a person is a hobbyist, then we represent them with blue, and if not, we represent them with orange. And once again, it turns out that a lot of the people who are programmers also say that programming is a hobby for them, and especially so in the initial years. So in the initial years, to get through the initial years, it will really help for you to just have programming as a hobby, something that you do just to build things, just to solve problems, just something that you do on the weekend. And if you do that, then you will probably also have a long and fulfilling career in programming. So these are some inferences that we can draw from the scatter plot. We can also look at the distribution of the age first code column, so just to see when people have tried programming for the first time. And as you might suspect, a lot of people have some exposure to programming. Maybe they've written a first line of code, maybe a simple HTML page, or maybe just a hello world program. And Python's hello world is just this, right? So you can just type Python into a terminal and you just say print hello world, and that's your first program. But that by itself tells you what programming is. So it seems like a lot of people have been exposed to programming in their teens, and it depends on pretty much every field. You end up writing some code. So in Excel you write formulas, in different streams of engineering you probably use MATLAB or maybe some kind of a numerical computing package. Of course in computer science you write programs. If you're doing right now, in pretty much every field there is some code that you're writing, so it's not surprising that people get some exposure to programming at an early age. But then there are also people who have experienced this after a certain age. Like you can see a lot of people doing so after the age of 30 and after the age of 40, and there is like a small number of people who have even become exposed to it all the way up to the age of 80. So there are people from all ages and walks of life who are learning to code. Okay. Now, here are a few questions that you can try and answer. How does the experience change opinions and preferences? So maybe what you can do is you can repeat the entire analysis while comparing the responses of people who have more than 10 years of professional programming experience. Like which languages do they use? Which languages do they want to learn? With those who do not have that, and this is going back to like students versus professionals. Now you can have three categories: students, professionals, and experienced professionals. And do you see any interesting trends? Do you see what one might call a generation gap in terms of the coders from the old days versus coders, people who are learning it right now? What kind of roles do they occupy? What kind of languages do they prefer? And maybe you can also try and compare the years of professional coding experience across different genders, just to see if, and my guess is you might see that, although minorities are underrepresented right now, there are very few women, but my guess is you will see that there are more women now than there used to be earlier. So it's definitely things are improving, and you can try and validate that. So that's one way, if you can try and compare the years of professional coding experience across different genders. So with that, we have barely scratched the surface here. We have almost been talking for about 90 minutes, and we've already gotten a huge load of insights, and hopefully you're thinking of many more questions that you would like to ask and answer using the data. We've not even used all the 20 columns, only about 12 or 13 columns have been used, and then there are another 45 columns to pick from. So you can use these empty cells below to ask and answer more questions. So I'll let you try out, and you can try out all of these exercises. So there's really no end to this. The more you do, the more you experiment, the more you exercise these skills, the better you get at it. Now I've used fairly simple charts. I've not done many breakdowns. I wanted to leave that as an exercise for you, but try and replace each chart. So each chart or each graph that we have, try to use a different kind of graph, and maybe go through the Matplotlib gallery, go through the Seaborn gallery, and try and pick which might be an interesting graph to draw there. So these are all different exercises for you to try. Data analysis by itself is, there's a lot of depth in the field, and you can probably spend at least a few months just exploring different ways to slice and dice and analyze and visualize the data. So please do that. Okay, the best way to learn is by doing. Now, what we'll do is we'll just summarize some of our inferences and conclusions, and this is always a good thing to do at the end of your analysis. So here's some of the summaries. Like based on the demographic data, we can infer that the survey is somewhat representative of the overall programming community, although it definitely has fewer responses from programmers in non-English speaking countries and from women and non-binary genders. We have also learned that the programming community is probably not as diverse as it can be in terms of gender, in terms of age, maybe in terms of the different languages or the different countries that are there. So we should probably take more efforts and support and encourage members of underrepresented communities. And race is another thing that we've not looked at, but that's another factor where there's a lot of disparity. And we've learned that most programmers hold a college degree, and although a fairly large percentage of them did not have computer science as their major in college. So a computer science degree isn't compulsory to learn to code or to build a career in programming, but some STEM education definitely helps. And a significant percentage of programmers either work part-time or as freelancers. 10% is actually a pretty good number. And this can be a great way for you to break into the field, not just in programming, but also in data science, which are very closely related fields. We learned that JavaScript and HTML are the most popular programming languages used in 2020. And then we learned that Python is the language most people are interested in learning. And we've learned that Rust and TypeScript are the most loved languages, both of which are small but fast growing communities. And finally, it seems like programmers around the world seem to be working on 40 hours on average, but there are slight variations by country. And finally, we learned that you can learn and start programming professionally at any age, and you're likely to have a long and fulfilling career if you also enjoy programming as a hobby. And especially it's going to help you during the first few years. Alright, so that's our analysis. And as I said, there's a wealth of information to be discovered, and we've barely scratched the surface. So there are a few more ideas that I wanted to share with you. You can repeat the analysis for different age groups and genders and compare the results. Specifically, try and pick a slice of responses that represents you, right? So maybe the country you're from, the gender, the age group that you're in, and try and see what the preferences of people are and see if that reflects your opinions too. Try and choose a different set of columns. We've chosen 20 out of 65 and we've used about 12 of them. So you can look at a lot of the other columns, go through the README, go through the survey. Prepare an analysis focusing on diversity. So identify the areas where underrepresented communities are at par with the majority. So you might see that in education, actually, there's probably not a big difference in terms of the percentages of degrees that or different degrees held by people. But then there are places where there are differences like salaries. You will see that there is definitely a pay gap, and you can try and validate that. And try to compare the results of this year's survey with the previous year and identify some interesting trends, because this is data that you get every year. And once again, you can go back to this link, stackoverflow.com, insights.stackoverflow.com, and you can download the raw data for every year. Now, one interesting exercise for you to do is to see the survey results. So you can see that this is a pretty long analysis that they've done a whole bunch of analysis on pretty much the similar questions that we have answered. So see the survey results and try to replicate the survey results graph for graph. This could be a great way for you to just see if you are doing the same kind of data cleaning and analysis and simplifications and see how that affects your results. Now, if you can replicate all of these results, now that's a great sign that this is real world data and this is a large data set and this is a real analysis. So that's a real sign that you've done something significant in data analysis, and you can proudly then showcase that on your professional profile. Then we have this, I just want to share a few references. Now, we've used Pandas, Matplotlib, and Seaborn, so you can refer to the previous lectures. We've linked, you just go to 0topandas.com and you can find the lectures there, you can watch those lectures. Or you can also just go through the documentation and the user guides. So you have the Pandas, Matplotlib, and Seaborn user guides. Also go through galleries on Matplotlib websites. So these galleries will show you all the different types of charts that you can create using these libraries. And finally, as I told you, we are creating this open datasets library, Python package, which is a curated collection of datasets for data analysis and machine learning. So far we have about 6-7 datasets, but we are planning to add about 100 datasets here. So over the next few days, and we've released this library just yesterday. It's something that we worked up quickly to make sure that it's easy for you to download these datasets. So we are going to add about 100 datasets here. So you can use these 100 datasets for your course project as well. Okay. And that is the next step that I want to talk to you about. Now we've looked at this